Yeah. Thanks for your patience, everybody. All right, this is listen up. This is oxygen acetylene torch. Okay. Oxygen, green, acetylene, the red hose. That means it's the fuel. Okay, this acetylene is highly explosive. You've probably heard this in other lectures by other guys. Okay. Tonight we're going to demonstrate this scarfing tip, which is the curved tip. They look like this. Anybody see this? Everybody see this?
Yeah.
It's a curved tip. Now sometimes you think, wow, that got hot and bent, or somebody dropped it, or something weird happened at the factory. No. This is a scarfing tip that people actually use in the field, all right? It's designed that way. Now, let's say you got a bunch of bumps and crap on your table. This makes perfect sense for cutting it off the table down flat, right? I don't want to cut straight through. Now, you see the straight tip?
Yeah.
Nice and straight, right? That's for cutting these holes here straight through, right? But if you want to cut on the side, that's a scarfing tip. All right, so make sure you remember the word scarfing, because if an employer or boss ever wants to quiz you on that, or maybe he's never seen it himself, now you know what that is and what it's for. It's for cutting and trimming on the side, okay? Another useful thing for the scarfing tip, let's say I want to cut this weld out. It's got a crack or some defect in it. I can literally cut this weld out and replace it with a new weld. Alright, and in a minute I'll show you the carbon arc. It's very similar to what you can do with a scarfing tip. It's basically for gouging. So if I wanted to use the carbon arc, I could gouge this out with the carbon arc, and we'll demonstrate it on some of these welds. Now the best place for gouging or scarfing is to take out an existing weld and then put a new weld back in. Now it's a little bit complicated because, okay, you're gonna create a heat affected zone, and it may or may not be good for you. On situations like heavy equipment, it doesn't hurt it at all. You can cut out old welds or cut down extra material. Just cut it down and then start building it back up with new weld. Okay. Now, one thing I know from experience, you want to cut as little metal as possible in pretty much any situation, any type of cutting. So you cut down the minimum, and that's it. You know, cut as little, because you're saving somebody money and time by cutting as little as possible. All right, let's cut down some of these bumps, and just to see how it's acting. All right, I hate these bumps, right? So let's cut some of these off. All right, you set this torch the same way as the straight tip. You tighten up the, you get your acetylene flame, and you add the oxygen until you pull the trigger and tighten up the blue flame. All right, that's set. All right, did any of you notice is that faster or slower than grinding? Faster, much faster. All right, cutting a hole like that is much faster than drilling. Okay, it's slightly less accurate than drilling. All right, so depending on your circle cutters, okay, torching is often a very fast way of doing it. Another thing I forgot to mention is if you have concrete on the inside of a pipe, metal on the outside of the pipe, you can't cut through concrete, can you? So with the straight tip. So we take the curved tip, let's say this is the concrete, and this is the pipe, okay? We just turn on our torch, and we cut the pipe right on top of the concrete, right? right, did you like that? All right, let's cut this center out. All right, I'm going to cut this existing rusty, crappy weld out. All right, come look at this. That was fast and clean. It wasn't all the way through, was it? See how it's just gouging it? Isn't that beautiful? A beautiful idea to be able to gouge that without cutting all the way through. See that?
Yeah, we were just in the Thursday we got river 6.
Yeah, number 6 rebar. It's big, huh?
The quickie saw.
Yeah, quickie saw takes forever. And this thing is very fast. He's right, on big, huge. My dad cut a 4-inch solid round. 4-inch solid round. Yeah. He cut it in about a minute and a half. Which is and he didn't cut it from the edge. He cut it from the center, and he won a torch. He beat about 200 different guys. He's the fastest guy. And then my brother was second best. Because people that have a lot of experience with torch, you know, it's actually kind of fun. All right, I would love to see you guys practicing. All right, I'm going to do half of this bar over here, cut the weld out. Now, what I'm looking for is that air pocket or some little change in the metal. Once you get to a certain depth, once the weld is gone, I can see the little crack. See that? I don't need to see very much. I just see the little crack between the two pieces, and I know I've got rid of the whole weld. The weld is gone when I see the crack. So that's how I know how deep I am. You can see it. All right. All right. I'm going to try and go down until the weld is gone in this one. Yeah, I'm glad that happened. That's usually a bad sign. That's why they have low back protectors. What are those called anyway? That's kind of a dangerous thing, but you don't have to worry. All right, it's pretty fast. I'm going to finish this bar with the carbon arcing so you can see how that works. Here's a common one right here. Let me see if I can turn this around the right way. All right, basically I'm going to cut this weld right here. You can hold it almost straight up and down, do the same thing. All right, it's a pretty clean cut. If you notice, anybody notice that I'm using it backwards that time? Normally you go like that. You can also go like that. It has some reason you can still get alongside of it, but basically you're just watching that molten puddle do what you need it to do. All right. don't know if that's going to stay right there.
You turn around.
No, I'm going to cut this one right here. And that plate will just drop right off. It's going to be, I'm going to show you that it's a pretty clean cut. And after this cut, Ernesto, we're going to turn on the welder and go to the carbon arc. Hope that works. You see that fire coming up the center here? It could be dangerous. You got to be careful. Alright, so this whole, that whole edge is, I'm going to go ahead and gouge that real quick. Thanks for your help. Right there, that's fine. Now watch out, I'm going to shoot it that way, okay? Yeah, I apologize.
When that happens, just turn it off.
Yeah, turn it off. Turn your fuel off. Assembly is the first one I turn on. First one I turn on and first one off. Alright, so that plate should come off, should basically fall off. Use my hammer. Alright, so if you notice, this is relatively clean. It won't take me, I can either use a torch to finish cleaning it a little or a grinder. And this piece and this piece are both basically clean. When they started out, totally welded in garbage. Okay, I've cleaned them off. That's basically a clean cut there on the edge. Clean cuts on all the edges, and now I can reuse those pieces, okay? Right, that's a very valuable benefit of the scarfing tip, okay? All right, let's fire up that welder. Thank you, good job, guys. All right, now, you guys get your welding hoods, okay, if you want to watch this. You probably didn't realize that this is the same as a welding arc in strength. Alright, the torch is a much, I guess, not as bright or cooler. It's not electric. Alright, this is an electric arc. Now we have the ground. Put the ground up to the table, would you? Should be laying here somewhere. Alright. This is pure carbon wrapped in copper. Alright? That's literally copper on carbon. That's a solid carbon rod, okay? Alright. We don't clamp the carbon side in, we clamp the copper side in. I'm going to start with a small one. Alright, I want you to crank the amps pretty much all the way up. Who's my... Alright, crank the thing up to like maximum, basically maximum is fine. Alright, I haven't tried this yet, but I've tried it many times in the past, but let's hope this works. Alright, you ready? Yeah, everybody get your hoods down, good. Alright, here's my air. Alright, I just discovered it's on backwards. Alright, there's a little, everybody lift your hoods for a second. Alright, there's a blast of air that comes out of here. See that? Alright, that's what's going to blow the steel away, okay? So I'm going to create an arc puddle and then blow it away, okay? Everybody ready? Hoods down. Ready? Hoods down. Alright, ready? We're going to do it again. Ready? That's bright, huh?
Yeah.
Alright, basically, we get the same sort of gouging with this, and if I have my machine settings perfect right, it would be a beautiful gouge across there. It would be an even cleaner gouge, and we would have done it a lot faster. I apologize, we didn't test this machine beforehand. Whatever setting, we don't have it right. So, but this machine is 400 amp machine is good enough for gouging. Obviously it takes a lot of electricity to heat that carbon up and gouge that out. But the beautiful thing about, go ahead and shut that machine off. Gouging definitely has its advantages. I don't know if you noticed that, but I have three different sizes here. There's many other sizes. There's smaller and bigger sizes. So to power a machine that would give you that much arc that's probably 500-600 amps right there. It's a very large machine, okay? And it's hard on these machines, okay? I much prefer this torch because the amount of energy in that acetylene and the control I have is valuable, and it's not as bad on your ears. All this air blasting, you got to have an air compressor and a very large machine. But this does have its advantages. One place where this carbon arc has advantage is hard facing or hardened steel or military steel or the abrasive resistant steels. This stuff will cut it when the torch will not cut it. I'm not sure if this will work on stainless. No, we're fine. I mean, thank you for the effort. I think everybody kind of sees what's happening here. You create it, when this thing is smooth sailing, this thing would I could probably go an inch every second. You know, it's pretty fast, and it would be a perfect groove the size of this carbon. If I went smaller carbon, I have a smaller groove, and it would just blast it out of there pretty fast. Alright, so like I was saying, those hardened steels, hard facing steels, if you got a drill bit that's covered in hard facing, you're not going to cut it at all with a torch, okay? Certain things will not cut with a torch. But this stuff will blast it away. It's kind of like plasma will go through any kind of metal. This will go through quite a few different metals because of the carbon. The carbon's a very high temperature and it conducts electricity. Alright, any questions? What do you guys want to know about scarfing tips, straight tips, and or carbon arcing? Anything? Here's one thing, I used to think old people were crazy. I'd see the old welder guys cleaning his tip. I'm like, man, this guy's wasting his whole day cleaning his tip. Have you seen him doing that?
Yeah.
So the main importance of cleaning your tip is this center hole. Okay, if the center hole is straight and clean, there's what happens is that gives you zero or very low turbulence in your weld or cut area. I mean, so when you're cutting this these puddles, let me slide this down. All right, you see these these are kind of crappy cuts, but they're better than most guys. They're full of welds now too, but most guys can't even cut that nice of a hole. Now, step one, clean your tip. If your boss is mad because you clean your tip, he doesn't know what he's talking about. All right, I know some guys do take too long to make a cut or too long to make a weld, but if you just get on with it, clean this tip real quick, you could probably make 1 or 2 or 3 cuts like this, and then clean your center hole at least again. Clean your tip again, okay? Try not to use a grinder or power tools on these. Use these nice little files and make it a very controlled cleaning, okay? This is not as important, cleaning this. In fact, this will kind of mess up your tip point a little bit. But the main important thing, the last step, is clean the center hole last. Okay, these other holes are for basically preheating and allowing the oxygen to enter into the flame, okay? The center hole is basically pure oxygen, which throws out the molten pool, okay? What did I miss? Anybody? All right, so straight lines with these, with the straight tip and cutting straight lines, the best trick is either get very comfortable and follow that cut, that line that you marked, follow it carefully or exactly, or you can also use flat bar, clamp down a flat bar, and go ahead and trace along it. You know, you probably need a bigger flat bar or something because you see the height of your flame, you have to be the same height as your flame, about a 3/16 to 1/8 of an inch to the table, or your work, obviously. You can follow a straight edge. All right, you can also take a washer, big washers, or any kind of a hole pattern, and trace that, and it'll give you a perfect circle every time. The only way you can screw it up is if you're pointing at a bad angle. If you keep it at a square angle, you'll have a square cut.
Yeah.
An angle cut,
If
if you're at an angle, you'll have an angle cut. Now imagine cutting this hole with an angle cut the whole way. You'll have a hole that goes that way, okay? So if you want a straight cut, you need
a torpedo.
Yeah, but okay, this table isn't level, is it? So basically you're square with the table. You're not level with the table. You're square with the table, right? Which I'm not saying you made a mistake here, but people don't realize we rarely level things in the welding business. We square everything, okay? So just one of the many tips.
You guys get those real tall beams.
Yeah.
Some a bit layer, and we go and check the beams.
Yeah.
Right in the money.
Oh yeah.
Everyone.
Oh yeah, those got to be level. Those better be level, or you got a building sitting on something crazy. But in the pipe world, okay, you do not know if it's going to be level. You don't even know. It may be climbing this mountain to the other side of the valley, okay? You're square with the pipe. Always square with the pipe and level on a building. Yeah. All right, good advice, man. Thank you for your help.
No problem. Thank you for telling.
Email me if you got any more questions. Call me if you got any more questions, all right? WeldComm.com. Thank you.
Thank you.